Good evening, everyone. We are High Country Engineering. My name is Tiffany McCremens.
I'm Tazvangshi Kanogia.
And I'm Tyler Durzay.
And our client is Nestle Purina, located in Flagstaff, Arizona. Our Capstone is a continuation of Mesquite Engineering's Capstone project, which they were tasked to design an alternative roadway to allow for Purina employees to enter in the site. Our project specifically, we designed the retaining wall to manage the large cut from the proposed roadway. And as you can see from this figure here, this is our project site, and the proposed roadway will run parallel to the Friends property line towards the Nestle Purina parking lot.
For our retaining wall, we have the reinforced concrete cantilever wall with two different types of foundation, the continuous and the step. The continuous is basically a 700-foot wall straight through and through, and the step is stepped in series of 7 100-foot walls.
So when designing retaining walls, we have to consider three factors of safety: overturning, sliding, and bearing capacity failure. Overturning factor of safety is simply the moments resisting overturning over the moments of overturning. This needs to be a minimum of 2 or greater. The factor of sliding is a combination of the sum of vertical forces of the wall plus the cohesion along the base of the foundation and the resisting forces to sliding, all divided by the driving force of sliding. And this needs to be a factor of safety of at least 1.5 or greater. And for the factor of safety for bearing capacity, this is simply the ultimate load over the maximum load at the eccentricity. And this needs to be 3 or greater.
For our hydraulic management alternatives, we have the underground water storage, the detention pond, and the retention pond. The main difference we have in the detention and retention pond is that the detention pond attenuates a certain amount of water, while the retention pond retains all of the water that is collected.
So to come up with our amount of water we need to detain or retain, we used the ADOT rational method. We started by calculating the time of concentration, then using ADOT's rational method equation Q equals CIA. We were able to come up with our runoff values created by our artificial watershed there, and we then used those runoff values to calculate our volume. It was recommended by another professor that we increase the size by approximately 1/3 over the recommended size due to the fact that there have been 2 500-year flood events in the last few years. So we increased our required storage to 6,000 cubic feet, and then we decided to use the StormTech MC 7200 chambers to store the water underneath the roadway.
So for our impacts, we had positive and negative impacts for economic, environmental, and social. For economic, it will increase the traffic efficiency and the revenue of Nestle Purina. However, there would be a lot of capital cost in constructing the underground storage. For environmental, it will prevent soil erosion and give proper drainage to the deep cut the road requires, and it will also prevent contaminated water seepage. However, it does require a lot of concrete, which in turn also disrupts a lot of the native land there. For social, it will create a lot of jobs during construction and also provide easier access to the workplace. However, there will be a lot of traffic delays during construction.